We are going to continue with lesson 14, solutions of linear equations. In this case, remember, we always start with an example. Study the example problem showing how to solve an equation. We have the following example. You need to go over the problem. In this case, you have 6p equals to 1/2 4p plus 8. Then here is one way you can solve it. Okay, so we do, for example, in this case, I have 6p equals to 1/2 4p. What they did, they applied distributive property. See, 1/2 times 4, I'm going to do it here. 1/2 times 4 equals to 4 over 2, because we have a denominator, so 1 times 4 is 4, 2 times 1 is 2, and 4 divided by 2 is 2. And so we said 4 divided by 2 is equals to 2. That reason why you have 2p. And then 1/2 times 8 will be 8 divided by 2 equals to 4. Next step, in this case, we subtracted 2p, both sides of the equation, minus 2p minus 2p, so 6 minus 2 equals 4. Then we divide by 4, 4 divided by 4 is 1. So we simplify at the end, you follow those steps. So in this case, explain step number 1, and in this case, each of the terms, okay, step number 1, see it, that one, each of the terms inside the parentheses for p and 8 were multiplied by 1/2. That's what you're going to do, or that's what you did. So in this case, each of the terms inside the parentheses were multiplied. In this case, were 4p and 8 was multiplied by 1/2. So that's the answer for problem number 1. Those terms were multiplied by 1/2, applying distributive property. Then it says a different step. A different step, 1, for each example is shown below. So in this case, we multiply both sides by 2 and explain why both sides of the equations were multiplied by 2. What is the resulting equation? So if you multiply by 2, you get 2 times 6 is 12p. And then 2 times 1/2 is equals to 1. So you end up with 4p plus 8, because 2 times 1/2 is equals to 2 over 2 equals to 1. And 1 is not going to change when it's inside the parentheses. So in this case, explain why both sides of the equations were multiplied by 2. What is the resulting equation? So in this case, both sides were multiplied by 2 to eliminate the fraction. The resulting equation is 12p equals to 4p plus 8. So that's what you get. Then, number 3, what are the coefficients of p in the equation you wrote in problem number 2, in this one? Are they rational numbers? So in this case, you have 12 and 4. You can see 12 and 4 are the coefficients. Are they rational numbers? Yes, they are. Because 12 can be right as 12 over 1, see? Or 4 can be equals to 4 over 1. So they are rational numbers. Now, let's turn the page. Remember that rational number is a number that can be expressed as the quotient of two integers, or division. So 3 is equals to 3 over 1, 0.5 is equals to 5 over 10. Coefficient is the number multiplied by the variable in the variable term. 10 is the coefficient of the term 10x. It's the number with the variable. So let's move to problem number 4. Solve 2 different ways. It says 2 different ways. Let me move the camera, moving the camera. Solve 2 different ways. Show 2 different ways to solve these equations. So in this case, I'm going to do, I have 2 over 3, 3x plus 6 equals to 4x plus 3. Okay. I think I need to move this one here. Okay, better. Now, what I'm going to do, I'm going to multiply 3 both sides of the equation. Okay, I'm going to multiply 3 both sides of the equation to get rid of the denominator. So times 3 times, and then times 3. So what happens? The denominator goes away. So you have 2, 3x plus 6 equals to 3, 4x plus 3. Then you apply distributive property, both sides of the equation. So we have 2 times 3, 6x. 2 times 6 is equals to 12, equals to 3 times 4 is equals to 12, x, 3 times 3 is 9. Now, what I'm going to do, I'm going to subtract 6x in both sides of the equation. So minus 6x minus 6x. So I have 12 equals 12 minus 6 is 6x plus 9. Now the next step is get rid of 9, minus 9. So this goes away. So 12 minus 9 is equals to 3, equals to 6x. And we divide, final step, divide by 6. So we end it with 1/3, 1/2 equals to x. Or x equals to 1/2. That's one way. Where's the second way? Okay, see if I have. So the second form of this equation that we're going to solve, we are going to apply distributive property, okay? And we multiply 2 over 3 times 3, which is equals to 2 times 3, 6 over 3 equals to 2. So 2/3 times 3x is equals to 2x. And then we multiply 2 over 3 times 6 is equals to 12 over 3. And 12 divided by 3 is equals to 4. So 2x plus 4 equals to 4x plus 3. I'm going to get rid of this 2x. So I'm going to minus 2x minus 2x. So this one goes away. So 4 equals to 4 minus 2 is 2x plus 3. Move 3 to the left. So minus 3 minus 3. So 1 is equals to 2x, and then we divide by 2. So x is equals to 1/2. We get the same solution. Less steps, as you can see, but in this case you need to know how to multiply fractions. So, and sometimes we have problems multiplying fractions. So in this case the solution is x equals to 1/2. Now next one, Kobe's solution for 4x plus 3 equals to 1/2 plus 2 is shown at the right. Did he solve the equation correctly? Explain why or why not. Let's take a look. So in this case, from this step here, apply distributive property, 4x negative 12. 12, then he multiplied by 2. So 8, here's the mistake. Okay, there is a mistake. 2 times 4 is 8. 2 times 12, he did not multiply 12. So there is a mistake. This answer is not correct. So in this case, I'm going to say, no, he did not. Okay. And then you explain why, okay? So in this case, he did not apply the distributive property correctly when he multiplied each side of the equation by 2. Okay, the result should be ax minus 24 equals to x plus 4. So if you multiply 2 times 4, 8, 2 times negative 12, negative 24. Okay, so if we continue this way, okay, this will be the correct answer, not ax minus 12 equals to x plus 2. Okay, that's incorrect. And in this case, the solution, here I'm going to write, and the solution should be x equals to 4. That will be the solution. Number 6, in the equation 3x minus 1 equals to 2x plus c, for what value of c will x equals to 3? Explain your reasoning. What I'm going to do, you can make the substitution of x by 3 and then solve for c, okay? Let me write this one. I can simplify the equation to x minus 3, and I'm going to explain where is that one coming from, okay? So in this case, for example, look at this one. 3x minus 1, this is 3, equals to 2x plus c. Let me simplify all, apply distributive property. 3 times x is 3x. 3 times 1 negative 3 equals to 2x plus c. Now let me get rid of this 2x. So let me get rid of that 2x minus 2x. So I have 3 minus 2 is x minus 3 equals to c. Now, what is the value of x? Is 3. So let me substitute. So 3 minus 3, okay, minus 3 is equals to c. And 3 minus 3 is 0. So c is equals to 0. So that should be the value of c. So in this case, when c equals to 0, then we have that x equals to 3. So in this case, c has to be equals to 0. So this is, let me do the next page. Okay, so I have the following one. Still the same homework. Lesson 14. Study the example showing how to identify the number of solutions an equation has. So we have all over. Remember that we were talking about infinitely many solutions, no solutions, and one solution. So if you follow this reading, you're going to understand. So if you have infinitely many solutions, left and right have to be the same, equal. 2x plus 5 equals to 2x plus 5. Or if you have just two numbers, 4 equals to 4. An equation has no solution when you simplify and the variable terms on each side are the same, but the constants are different. For example, 2x plus 5 equals to 2x plus 3. So the variables cancels out, and then you have that 5 is equals to 3, which is not true, so it's not a solution. And last one, an equation has one solution when the variable terms on each side are different. So are different, as in 3x plus 1 equals to 2x minus 5. Okay, so in this case, problem number 1, we have in this page 163. Suppose the right side of the equation in the example problem is 2x minus 3 plus 8. How many solutions will the equation have? So in this case, we're going to have infinitely many solutions. If we simplify, 2x minus 3 plus 8 is equals to 2x plus 5, which is the same here, which is the same as the left side. So if we simplify this side, we get the same as the left. So we can get infinitely many solutions. Now, as I said, you can just, the two sides will simplify to the true sentence two x plus 5 equals to 2x plus 5. Okay, number 2. Suppose the right side of the equation in the example, okay, the right side of the equation in the example problem is 3x minus 3 equals to 6. How many solutions will the equation have? Okay, let me write this one here. So I have 2x plus 5 equals to 3x minus 3 plus 6. So what we're going to do, simplify the right side. So 2x plus 5 equals to 3x plus 3. Look at the coefficients of the x is different. They are different. So in this case, you're going to have one solution. So here, one solution, Okay, that's going to be your answer. Number 3, look at the model at the right. Okay, look at the one at the right. Does it represent an equation that has one solution, no solution, or infinitely many solutions? Explain how you know. So in this case, you have 2x, okay, 2x, and I'm going to say plus 2, those two elements. And then you have 1x equals to 1x plus 3. See that the coefficient of the variables they are different. So in this case, one solution. In this case, I'm going to say, for example, the model shows 2x plus 2 equals to x plus 3, as I mentioned. The variable terms are different, so there is one solution. One solution. Okay, so if we turn to page 164, we're going to have the following equation. Consider the equation cx minus d equals to 2x plus 4. Replace c in the equations with 2. For what values of d will the equation have infinitely many solutions? So what we're going to do. Okay, so let me write the equation here. So I have cx, but replace c with 2, so 2x minus d equals to 2x plus 4. Now, which value of d will make left and right the same number? Okay, remember that this, and look at this number is positive 4, and this one is negative d. So I will have to put inside negative 4, because negative and negative is positive, so 2x minus negative 4 equals to 2x plus 4. So 2x plus 4 equals to 2x plus 4. That's what we're going to do. So in this case, I'm going to have d equals to negative 4. Okay, explain. Why? Always they are asking us to explain why. So in this case, I'm going to say for the equation, (2x minus d) equals to 2x plus 4. To have infinite many solutions, the variable terms and the constants on each side must be the same. Okay, so if d equals negative 4, we have 2x minus negative 4 equals to 2x plus 4, and I did that step here, and you get the same. Okay, now b, replace d in the equations with 2. For what values of c will the equation have no solution? Okay, so let's write this one. So I have cx minus d equals to 2x plus 4. So they are asking me to replace d for 2. So x minus 2 equals to 2x plus 4. Okay, remember that the constants of the coefficients have to be the same, and the y-intercept needs to be different. So in this case, I'm going to say for b is 2. So if you put 2x minus 2 equals to 2x plus 4, you're going to get no solution. So in this case, I'm going to say c equals 2, comma, and I'm going to say for the equation, cx minus 2 equals to 2x plus 4. To have no solutions, the variable terms on each side must be the same and the constants must be different. Okay, number 5. You have that Evelyn says that the equation 3, parentheses x minus 3 plus 5 equals to 3x plus 5 plus 4, has infinitely many solutions because the variable terms on each side are the same. Do you agree with Evelyn? To give an answer, you need to simplify that equation. For example, 3 times x is 3x. 3 times negative 3 is negative 9 plus 5 equals to 3x. 1 plus 4 is 5. Okay. Now look at this one. Negative 9 plus 5 is equals to, in this case, negative 4. So 3x minus 4 equals to 3x plus 5. Coefficients are the same. Y-intercepts are different. That's no solution. So in this case, no, I do not agree with her. And what happens? He did not, well, in this case, what we're going to have for no is I do not agree. Okay. Because when you simplify, those coefficients are different. So I'm going to leave it there, number 5. Number 6, explain why the equation 5, 2x plus 1 minus 2 equals to 6x plus 5 has only one solution. Find the solution. Okay, so 5 times 2 is 10x. 5 times 1 is 5. Minus 2 equals to 6x plus 5. Then 5 minus 2 is 3. 10x plus 3 equals to 6x plus 5. I'm going to move 6x minus 6x minus 6x. So this 2 goes away. 4x plus 3 is equals to 5. Then minus 3. So in this case, I have 4x equals to 2. So x, we're going to divide by 4. So I have equals to 2 over 4. And if we simplify here, x is equals to 1/2. So that's the solution, 1/2. Okay. So we simplified. You can write over there number 6. When you simplify both sides of the equations, you get 10x plus 3 equals to 6x plus 5. The coefficients are different. The y-intercept are different, so you only get one solution. Number 7, the last one. It says write an equation that has one solution, then write an equation that has no solution, and write an equation that has infinitely many solutions. Each equation should have one variable term on each side and the total term. So in this case, one solution, for example. Remember, I'm just going to write numbers with the conditions that we know. If you want one solution, the terms in the coefficients in each term have to be different. So for example, 3x minus 2 is equals to 2x plus 2. Variable terms are different, one solution. No solution. The variable terms are the same and y-intercepts are different. So for example, 4x plus 1 equals to 4x plus 3. Infinitely many solutions, left and right have to be the same. For example, 3x plus 2, I'm going to use 3x plus 2 equals to 3x plus 2. And that's the solution for pages 161, 62, 63, 64 of lesson number 14. Part 2 will be up later. Have a wonderful day.